8.4. Let's put that up in the corner so we can keep track of it on the videos. Page 547, problem number 2. Problems 1 through 12. We're supposed to find the area of each region. Well, I said I was doing better. So what we have here for problem 2 is a square with a triangle attached. So what's the area of the square if it's 3 by 3? 9, right? What's the area of the triangle if it's 2 by 3? How do we know it's 2 by 3? Because the whole bottom length is how long? 5, and if this much of it is 3, then this would have to be 2, wouldn't it? And what's the area of a triangle that's 2 by 3? 2 times 3 is 6, but it's 1/2 of the base times the height. So that would be 3. So the total area would be 12. Well, that was easy enough. Are they all going to be that easy? Number 10. Let's look and see. Number 10 is a triangle with a semicircle attached to it. And the triangle, it says, is, I mean, if it makes you feel better to turn it up like that, is 20 across the bottom. And how tall is it? 25. So 1/2 base times the height, 20 times 25 times 1/2 would be 250.
So, how do you find the area of a triangle?
1/2 the base times the height.
Okay.
And the reason for that is if we made a rectangle out of this, that would be 20 by 25, but the triangle is only half of that.
Okay.
So you always take half of what would have been a rectangle to get the triangle.
Is it that way with all triangles?
All triangles. Then the semicircle, that semicircle, we'll have to find the area of the circle and then take half of it for a semicircle. Why is that thing bouncing around? Huh. That'll help. Push over here a little bit. So, what's the area of that circle? Well, what's it say? It says its radius is 10 and the area is what? Pi times the radius squared. So the area of the whole circle would be pi times 10 squared, or 100 pi. So the semicircle, half of it would be 50 pi. You follow that? So what do we have here? 250 plus 50 pi. Is that all they want us to do? Find the area of each region. Number 12. All right. What do we have here for number 12? We've got two semicircles. And this semicircle has a radius of 10, and this semicircle has a radius of 5. Isn't that what it says? So if we did the whole circle, let's just change colors here. If we did the whole circle and said what's the area of the whole circle, that would be, with the area is pi times the radius squared for a circle. The radius is 10, so this whole thing would be pi times 10 squared, or 100 pi. That would be the whole circle. If we only wanted half of it, that would be 50 pi. Now let's do the little circle. What's wrong with that? Marker's already shot. That would be pi times the radius squared. That would be 25 pi. Half of that would be 12.5 pi. My goodness. Where did I get these cheap markers anyway? So we would have 50 pi minus 12.5 pi. That would leave us with 50.5, no, 50.0 minus 12.5, 5, 9, 7, 4, 3. 37.5 pi would be the area. I mean, that would be the area of this little region right here. See what we did? We took the whole circle and took half of it, then subtracted this half of the circle from in here. And that takes care of the region that they're showing a picture of. Did you follow that one? In problems 13 through 16, find the shaded region. All right. Do all of you see in number 13, the one you're going to work, you just have half of a square with a semicircle subtracted from it. For number 14, you have the big circle, which would be with a 6-inch radius. The area would be pi times 6 squared, 36 pi. But then you want to subtract that part in the middle that's white, which is pi times 4 squared, which is 16 pi. So you have 36 pi minus 16 pi, leaves you with 20 pi. Number 16. What do we have for number 16? A big square. With a trapezoid. What is this rectangle? This is 8 by 6. But it's got this trapezoid cut out of the middle. Do all of you know how to find the area of a trapezoid? You know the formula for the area of a trapezoid?
Well, I mean, you just find the pyramids on the side, right?
Well, if you don't know the formula, look what can happen. This is 3 inches, it says, right?
Mm-hmm.
I'm going to change that just a little bit, make it look more like the picture. And this one's 3 inches. And this one's 4 inches. Is that what they said? And this whole thing down here is 6 inches. So, if we made, see if one of these is going to work now. If we made a rectangle out of this, that rectangle would be what? 6 inches by 3 inches. You follow that?
Mm-hmm.
So the rectangle would be 18 inches. But you don't want the whole rectangle.
Mm-hmm.
You want to cut off this over here and this up here. So how do you do that? Well, here's the formula. See if it makes sense to you. The area of a trapezoid is 1/2 times base 1 plus base 2 times the height. Base 1 is 6, base 2 is 4. Add those two together. The height is 3, and then you take half of that. Because if you take 6 plus 4 times 3, that gives you 30. That's twice as much. You've calculated the area twice.
Mm-hmm.
So you take half of that, and the area is 15.
Okay.
Does that make sense?
Yeah.
So this area right here is 15. And this whole area is 48. So we go 48 minus 15, and that equals 33. And that's the area of the green region. Number 18. A rectangle is 24 inches long and 24 centimeters long and 7 centimeters wide. And 7. How long is this diagonal? That's what we want to know. You see what we have here? We have a right triangle. We know 7 and 24, and we want to find the hypotenuse. Do you know the Pythagorean theorem? Pythagorean theorem. Here's a right triangle. A, B, C, A squared plus B squared equals C squared. So that would be 7 squared plus 24 squared would equal, let's call it D for diagonal, would equal diagonal squared. What's 7 squared? 49. What's 24 squared? I don't have that on the top of my head. 24 times 24. 576 equals D squared. So what's 576 plus 49? 625. What's the square root of 625? 25. Everybody follow that? I just used my little square root button on my calculator, and I'm in business. Number 20. The two diagonals of a rhombus are 4 inches and 8 inches long respectively. One diagonal is 8 and the other one is 4. And there's the rhombus right there. What do they want to know? Find the length S of the sides of the rhombus. They want me to find this right here. If this whole thing is 8, that's 4. If this whole thing is 4, that's 2. Do you see my little right triangle there? With 4 and 2 and S. So Pythagoras says 2 squared plus 4 squared equals S squared. Everybody see that? So I have 4 plus 16 is S squared. So 20 is S squared. S is the square root of 20. Which would be what? 2 times the square root of 5. Do you remember doing radicals last semester in math? Good. If not, you might have to go back and look at that chapter again. 22. A telephone pole is supported by 2 cables attached to the pole 15 feet above the ground. So here's the telephone pole. And 15 feet up is a cable. Going down to the ground. Eight feet from the foot of the pole. So this is 8 feet over here, and this is 8 feet over here, and they want to know the total length of the cable. Well, what I'll do is I'll find the length of half of the cable by using my Pythagorean theorem, and then just double it. So we'll call this C, but it's only half of the C because there's another one over here. So that means 8 squared plus 15 squared equals C squared. Better get my calculator out for that one. Oh, I shouldn't have to do that. 8 squared is 64 plus 15 squared. I think it's 225. Sure enough, 225 equals C squared. What's 225 plus 64? 289. What's the square root of 289? What? 17. So that's 17, and that's 17, so the total length of the cable would be 34. I can't believe that came out even like that. That's pretty cool. You guys having as much fun as I am. This is kind of cool stuff, isn't it?
I like it when it comes out even.
Think of all the people who aren't missing out on all the fun we're having in here. Think about what good math teachers you're going to be because you've got all this math going for you. Number 24, the base of a parallelogram is 10 centimeters long. All right. So the base of a parallelogram is 10 centimeters long. What else does it say? The height is 5. And so the height here is 5. The longer diagonal is 13. That would be this diagonal from here up to here. Whoops, that's not a very good diagonal. Let's try that again. Why are these markers drying out so fast? Let me erase that, see if I can get it to work again. It's just not wanting to. All right, let's do purple then. Purple seems to want to work. So, what we have here is this diagonal. What we need to do is make a right triangle. Let's extend this out and come down like this. See what I just did? This is 5. This is 10 plus x. I don't know what that is. I just added on there. But what does it say that diagonal is? 13, doesn't it? So I have a triangle here. Now, try to make your lines halfway straight. Okay, I'll work on it. So this is 13, this is 5, and this is 10 plus x. So what's this going to say? 10 plus x squared plus 5 squared equals 13 squared. You follow me? I'm just using the height to make a right triangle using that long diagonal. And so I had to add some stuff on here to make it so it would include all of this. So now, what's 13 times 13? Isn't that 169? I don't know. Yeah. So I've got 169 equals 25 plus, what would that be? 100 plus 20x plus x squared. Does everyone remember how to do that binomial multiplication stuff? So now let's turn this around and go x squared plus 20x plus 125 minus 169 equals 0. So x squared plus 20x minus 44. Does that look right? Equals 0. So draw your two parentheses, x, and plus and minus. And how many ways can we get 44, a negative 44, that when you add them together, you get 20? Would that be 2 and 22? Negative 2 and positive 22? Would that work? So it looks like it's x minus 2 times x plus 22 equals 0. So either x is negative 22 or x is positive 2. Well, x can't be a negative number, so x has to be 2. So now we know this is 2. So what? If that's 2 over there, then what does it say to do next? How long is the shorter diagonal? That's the one from here to here. How long is that diagonal? Well, there's the right triangle. And how much is this? 2. What's 10 minus 2? 8. So this is 8. This is 5. And I'll bet I can use that to find this right here. 5 squared plus 8 squared equals d squared. 25 plus 64 is d squared. 89 is d squared, so d is the square root of 89. square root for 89. Doesn't come out even. What can I do with 89? 3 and 29. That's not right. Nope, I think I'll just leave it like it is. Square root of 89. Number 26. The floor of 3 rooms in a certain house measure 9 by 10. 9 by 10. 12 by 10. And what's the other one? 15 by 15. That's feet. You better put that on here. And how many square yards of carpet? See that? Square yards. Well, let's see. What's 15 feet times 15 feet? $225. 9 by 10, 90. 10 by 12, 120. So 225 square feet and 90 square feet and 120 square feet comes out to be 5, 9, 10, 11, 12, 13, 435 square feet. So how many square yards would that be? How many square feet in a square yard? Isn't a yard 3 feet by 3 feet? So 1 square yard is how many square feet? How many? 1 square yard is how many square feet?
9.
9. Nobody likes that. And when you teach that to little kids, you better just draw the picture and say, there's a yard. 1, 2, 3 feet, 1, 2, 3 feet. 1 square yard is 9 square feet. So 435 square feet, 435 divided by 9 would tell me, is that right? 48.3 square yards. Number 28. The Louisiana Superdome covers 363,000 square feet. I guess you know that Superdome is the shape of a circle. And that's 363,000 square feet. Is that what they said? What's the diameter of this arena? Area is pi times the radius squared. So 363,000 is pi times r squared. Well, did they tell us what to use for pi? That was nice. Use 3.14. 3.14. So I divide 363,000 divide by 3.14, and I get 115,605.09. Where's my decimal point? It looks like it's right there. Is that what you got? My calculator doesn't show decimal points very well. You'd think they'd do better than that, being it's an AARP calculator. Yeah, that's the right place. Okay. So that number equals r squared. So I take the square root button and I get r is 340. So the radius is 340. So what's that make the diameter? 680. Number 30, it's the same kind of problem, so let's go to number 32. Find the height of a triangle with an area of 70 square inches. Here's a triangle whose base is, what did they say? The base is 20. It's a triangle. And the height is what they want me to find. But they tell me that the area is what? 70 square inches. The area is 70. And the area is 1/2 base times the height. So 70 equals 1/2 times 20 times h. 1/2 of 20 is 10 times h equals 70. So h would have to be 7. Okay? Did I move too fast for you on that one? Number 34, diazinon, a toxic chemical, has been banned. Each ounce covers 125 square feet. 1 ounce covers 125 square feet. The transportation department used 32 ounces to spray a strip of grass. And the strip of grass was 16 inches wide. We just don't know how long it was. But we know what the area was, because 1 ounce covers this much, 32 ounces covers, what's 32 times 125? 4,000 square feet. So call this length 16 times L has to equal 4,000. So 4,000 divided by 16 tells me that the length was 250 feet. Do you follow what I did there? Let's see what the next page looks like. In problem 35, suppose John wants to decrease the 4-foot side and increase the 5-foot side so as to decrease the area by 3/4 of a square foot. I don't know why John wants to mess around like that, but what does John have here? He's got a piece of wood that's 4 by 5. And what does he want to do? He wants to decrease the 4-foot side and increase the 5-foot side by the same amount. So he wants to decrease this by X. Come on. Come on. That's just wrong. He wants to decrease this by X and increase this by X. So he wants a new table that's this long. Follow that? And this table, if this whole thing was 4, then this is 4 minus X, and this is 5 plus X. You follow that? So that's what his new table is going to look like. And the area is going to be 4 minus X times 5 plus X. But he wants that area to be what? 3/4 of a foot smaller than the original thing. And the original one would have been 20 minus 3/4 would be 19.25. So this area needs to equal 19.25. Can you do the factoring to solve that problem? See, these dimensions have to equal this area. 3/4 of a square foot less than what it was originally. Well, I'm going to have to leave that for you to work it because we have to keep going. 38. What happens to the area of a triangle if the length of its base is doubled? What happens to the area of the triangle? Here's a triangle with a base of 10 and a height of 5. So what's the area? 25. Let's double the base, and we still have a height of 5. What's the area? 50. So what happens if you double the base? It doubles the area. What if you double both the base and the height? Then that means this would be 10. That would be 100. 10 times 20, 200, half of that. If you double both of them, it increases the area 4 times. Number 43. I know that's one of yours, but I just don't think it's fair that he wants you to do this on your own. A regular octagon is formed, and this will be the last one. This is where we'll stop. I've got this square, and I'm going to form an octagon by cutting off the corners with little triangles. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. I got 8 sides, and even if the picture doesn't look like it, this is an octagon, so this is X, X, X. All these sides measure the same. You follow me? Now the question is, what did I do? I cut isosceles triangles from the 4 corners of a square. If the side of the square is A and the equal sides of the isosceles triangle are S, so this is S, 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 and this is S, and this whole thing here is A. So what am I going to do? This is a right triangle. Well, A equals S plus X plus S, right? A equals S plus X plus S. Okay? So I've got something going for me. And here, X equals, this is the right triangle, equals, okay, S squared plus S squared equals X squared. So 2S squared is X squared. So X is the square root of 2 times S. X equals the square root of 2 times S. So X equals the square root of 2 times S. So A equals S plus the square root of 2 times S plus S. So A equals 2S plus the square root of 2 times S. A equals S times 2 plus the square root of 2. You follow me so far? Where are they wanting us to end up? With S equals A divided by 2 plus the square root of 2. Does that look like what they show there in the book? Does S equals A over 2 plus the square root of 2 look like what they have written here?
No.
2 minus the square root of 2 times A over 2. Do you remember when we did this radical stuff that I'm going to settle down here so I don't get too dizzy today. Since this is the last one anyway. You remember when we did these irrational numbers? You couldn't leave this down like this. Math people don't like that. So you had to rationalize the denominator by taking both the top and bottom times 2 minus the square root of 2. And when you did this, you get 4 minus 2. So now we end up with A over 2 times 2 minus the square root of 2 equals S. Does that look like what's in the book there? Does this look like what they show in the book?
A is outside.
Oh, the A's outside? What, the A's out here?
Mm-hmm.
Yeah.
But it doesn't matter where you put the A, does it? We've got this and 2 and A. We've got 3 things to work with. So if you would have stopped here, you would have had a correct answer. It just wouldn't have been in what's called simplified form.
Okay.
And that could have driven you crazy trying to do that on your own. You probably could have figured that out on your own, couldn't you?
Maybe.
I thought real hard and real long about it.
Same.
And you have a lot of work to do to be thinking that long and hard about something in math.
Yeah.
And that's all I have to do, is to spend all my time thinking long and hard about math.
So what would the answer be? I'm still confused.
Well, we were just trying to show that.
See,
Oh, we're just trying to show.
you're
like,
trying to
how?
show that this turns out to be this.
So we need to write down all the steps.
Well, I don't know. You're welcome to. That's why I worked it for you. So I'll leave it up there, and then when you're finished, you can take off. And I'm going to sit here and rest for a while, and then go home and take a nap.
I have a couple of questions.
I will take your questions.
On problem 23,
Let me go turn this off over here.
so in problem 24 we found the diagonal